Hello, in this short video we're going to be discussing Section 7 of Chapter 10, Conservative and Non-Conservative Forces. So, conservative forces. The figure shows a particle that I'm moving through space from position A to position B. And let's imagine that it has two ways I could move it, right? Two paths I could take it on, either path 1 or path 2, while some force F is exerted on it. And a statement we can make is that if there's a potential energy associated with the force, this is a conservative force. And what does that mean? It means the work done by the force as the particle moves from A to B would be independent of the path followed. So if I took an object from A to B and I find that the forces acting on it are identical no matter how I brought it from A to B, we would call that a conservative force. And those forces lead to potential energies. The force does work on the particle as it moves from A to B. It's going to change the kinetic energy. But if it's a conservative force, then I end up with a potential energy. What are non-conservative forces then? If an object slides up or down a slope with friction, then it returns to the same position. It only loses kinetic energy in that example. Its kinetic energy is converted into potential energy, but also into thermal energy. And that thermal energy, right, is not efficiently transformed back into kinetic energy. So a force for which we cannot define a potential energy we call a non-conservative force. Some examples are like friction and drag that transform mechanical energy into thermal energy. We can also think about forces like tensions and thrust. These forces tend to care about the path. Think about friction. If I take an object, right, and I move it around in, say, a circular path, even though that object is continually returning to its same position, it's going to be losing kinetic energy. Why? Because that frictional force is always just following or pointing against the motion. Whereas for a conservative part, if the potential energy, change in potential energy is independent of the path, right? It means that if I came back right to where I started, then I wouldn't have a change in the potential energy and I should conserve my energy. It means if I follow path 1 and then return to point A through path 2, I should have the same kinetic energy and potential energies that I started with initially. Okay. For friction, that's not the case. As I go through path 1 and path 2, because the thermal energy of the system would be increasing the whole time, I'll have lost kinetic energy by the time I get back to that point. All right, that was our real quick discussion on conservative and non-conservative potential energies and forces.